Hello students, this is Mrs. Crawford. This is day, let's see, I think it's day 3 of this unit. I'm not entirely sure, but it is the one on power rule and zero power. So check at the top of your page, make sure that those are the topics that you're supposed to be watching the video on. First thing to fill in, power rule means when you raise an exponent to a power, so you really have 2 exponents there, you can actually multiply the exponents. Now, I'm going to show you how you can do that, but we're going to show you more the longhand route, which is what we discussed in class. Especially since you guys are just learning this, it's very easy to mess it up if you try and do this shortcut. So we're going to focus more on doing it the kind of longhand way so that you are less likely to make a mistake. So for example, if I had 2 to the 4th power, that really means 2 times 2 times 2 times 2, or 2 times itself 4 times, which is how we get 16. Now, we're going to apply the same idea here, only this time we're going to do it with the x power. So it's x to the 3rd 4 times. So this is really x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. The reason we're showing you this way is because now you actually have the same rule that you were dealing with the other day. If I have exponents multiplied all together, it's really like I'm adding up the exponents. There's 3 here, 3 here, 3 here, 3 here. If I add up 3 plus 3 plus 3 plus 3, I get x to the 12th. Now here's where the shortcut comes in. 3 times 4 is the same thing as 3 plus 3 plus 3 plus 3, which is 12. So you can use that trick. It's a little bit easier to use it on exponents. However, if you try and apply it to coefficients, you're kind of likely to make a mistake. So we would like you to do it the longhand way, at least for this first unit. Same thing here. This is just y by itself, and it's written out twice. Well, y times y is really y to the 1st times y to the 1st, which is in fact y to the 2nd power. And lastly, down here we have this whole thing is raised to the power of 2. Now that means that entire group in parentheses, 2r to the 4th, has to be written twice, including the 2, the coefficient in front. This is why we try and have you guys write it out fully, is so that you don't mess up when you do it with the coefficient. 2 times 2 we treat just like normal, so that's just 4. The exponents are the ones we add, so r to the 4th plus 4, we now have r to the 8th power, so there's our answer for those first 3. So pretty basic for those ones. Now we start to move up a little bit more into more upper level things. This one we have 3x w to the 4th, all of it is raised to the 3rd power, which means I'm going to write 3x w to the 4th times 3x w to the 4th times 3x w to the 4th. Yes, I would like you to write this out, especially since you guys are just learning these techniques. Now, make sure you know what your coefficients are. It's the same number for all of them. It's the 3. And remember, with coefficients, you don't treat them differently. So I'm going to do 3 times 3 times 3 like I normally would. Well, 3 times 3 is 9. 9 times 3 is 27. This is why we usually get mistakes. People just take the 3 and multiply it, and they get 9. And then we have a lot of mistakes with coefficients. Now we've got the x's. Now these are not just x by themselves. They're really x to the 1st power. Make sure you add up all of those 1s, and you end up with x to the 3rd, because 1 plus 1 plus 1. W's, we've got 4, 4, and 4. Remember, again, you should be adding up those numbers, so it's w to the 12th power. And again, it would have been semi-easy to figure it out if you multiplied the 3, but that's really not what we would like to do. It's very, very easy to mess it up if you try and use that shortcut when you're not used to it. Okay, this second one, or this last one, I guess it's only the second one. You'll notice there's a fraction bar here, which is a little different than what we normally see. You're going to focus on your parenthesis group first, get those powers out of the way. So I'll go ahead and write it out. Whole thing has to be repeated 3 times, because it's the 3rd power. We're not going to pay attention to this one for right now. Just going to leave it alone. Let's get this group figured out. We've got 5 times 5 times 5. 5 times 5 is 25. 25 times 5 again is 125. We have r to the third, r to the third, and r to the third. If I add up these threes, 3, 6, 9. So I have r to the 9th. And then I have t to the second, or t squared, repeated 3 times. And again, 2 plus 2 plus 2. I end up with t to the 6th power. So that's all that's on the numerator. So now I got to go back up to my problem up here. So I'm actually going to rewrite it over here. I'm going to put 125 r to the 9th, t to the 6th, and it's still over 5 r to the 4th, t, and I'm actually going to add a 1 to that because it's really t to the 1st. All right, one thing at a time. This is kind of like the combination stuff we did on block day. We've got 125 and 5. Okay, we'll divide those. If you type it in on your calculator, you should get 25, I believe. Remember, you're dividing those, you're not subtracting, so don't make it 120. These are regular coefficient numbers, so treat them as usual. You have r to the 9th on the top, and you're canceling out 4 of them, which means you're really going to subtract. So I now have r to the 5th power. Same thing with the t's. I have 6 on the top, 1 on the bottom. Really, I'm canceling out 1, so I'm subtracting, so it's t to the 5th power. They all go on the numerator because 9 versus 4 is bigger, 6 versus 1 is bigger. So there is my final answer for that one. All right, go ahead and pause here. Try these on your own. It's really going to help you to practice these on your own, just so you can kind of see where your mistakes are that you're making, and then press play when you're ready, and I will show you how to do these really quickly. Okay, so we have x squared 7 times. So I'm actually going to write out all of them, which hopefully you did too. 1, 2, 3, 4, 5, 6, 7. So 2, 4, 6, 8, 10, 12, 14. Should have been x to the 14th. This one, we're doing 3n to the 5th times 3n to the 5th. 3 times 3 is 9. If I add up the 5s, I get n to the 10th power. Got to repeat this whole group 3 times. Now, there's more than one way you could actually tackle this one. I'll show you this way first and then tell you. 7 times 7 times 7 again should equal 343. Check it on your calculator if you're not sure. I have x squared plus x squared plus x squared, so that's x to the 6th. And then 3 plus 3 plus 3 is x to the 9th. Now, here's the thing. These can be combined. You could have actually combined them up here and made them x to the 5th. They're right next to each other, which means multiplication. No matter how I did it, whether I add it all up here, whether I add it here, did it at the beginning, I'm still going to get that there should be 15 of them, x to the 15th power. This last one over here has a lot of stuff going on. So let's actually cut our work down a little bit. Think about what we just talked about in the last one and combine those. X to the 3rd times x to the 8th. If I add them up, I have x to the 11th, and then I can get rid of those. So just to shorten up our work, that whole thing still has to go to the 4th power. But now it's 2x to the 11th, y to the 6th. 2x to the 11th, y to the 6th. 2x to the 11th, y to the 6th. And I'll have to bring one down here because I don't have enough space. 2x to the 11th, y to the 6th. All right, so 2 times 2 is 4. 4 times 2 again is 8. 8 times 2 again is 16 on the top. So I'm going to move down here a little bit. I have x to the 11th plus 11 plus 11 plus 11. If I add all those up, it totals 44. And then I have 6 plus 6 plus 6 plus 6. So that's y to the 24th. And then I got to bring this denominator back in. Can't forget about that guy. So I have 4x really to the first power, and then y really to the first power again. Now I got to start combining top to bottom. So I have 16 divided by 4. Treat it just like normal. 16 divided by 4 is 4. I'm going to keep it on the top. And I now have x to the 44th over x to the first. Remember, with exponents, you don't divide. You actually are subtracting. It's like you're canceling out this 1x. So it's x to the 43rd. Okay, because you're subtracting. There's more of them up top. That's why I'm putting them there. And then the last group, y to the 24th. Take away one of them. You're left with 23 still on the top. Okay, so that's the power to power section. Hopefully you got all that stuff down. We're going to go into the zero section now. So this one's kind of tricky. Anything to the power of 0 becomes 1, not x to the 1. Okay, just the number 1. No x's, no exponents, just 1 by itself. And I'm going to show you why that's a true statement. Let's take a look at this guy. W to the 5th power really means this. W multiplied by itself 5 times. Same thing, top and bottom. Now we talked about before, if you have something divided by itself, you're actually going to cancel it out. That's how it works. W divided by W. Think about 10 divided by 10. That equals 1. 100 divided by 100. That equals 1. Negative 10 divided by negative 10 still equals 1. So W divided by W is going to equal 1, which really means it cancels out. If I put a 1 there, it doesn't really change anything here because it's being multiplied. Same thing with this group and this group and this group. So they all cancel out. So I'm just left with the number 1. Okay? Now that makes sense when we're dividing things out, but how do we get this power of 0 worked in? Well, let's say we didn't know this rule about dividing. Let's say we only knew that when we divide exponents, you have to subtract their numbers. Well, what's 5 minus 5? 0. So it would be w to the 0. Well, if doing it this way gets me 1, and doing it this way gets me w to the 0, that means those two things have to be equal to each other. So anytime you have something to the power of 0, it actually just equals the number 1. So if I take a look at the second one, I'm actually going to circle the piece that is to the 0 power, which is just the x. Now the 3 is not to the 0 power. That's just a coefficient out in front, so I'm going to rewrite that. And then it's time x to the 0, which is really just the number 1. Notice there's no x there anymore, and really I get that the answer is 3. Very similar problem here. This is the only thing that is to the 0 power. So circle it. Now I've got 1 in front, and then still y to the 3rd, which really just by itself is y to the 3rd. So notice I'm circling everything that is affected by the 0 power. Okay, now a little different here. You've got some parentheses, and you notice the 0 is on the outside. That means this entire group in parentheses is affected by the 0 power. What do we just say anything to the 0 power is? 1, just the number 1. If that whole group is to the 0 power, it all just becomes the number 1. Same thing here. It doesn't matter if there's a 7,000, x to the 50th, whatever. It's all to the 0, so it's just 1. Everything goes away, just the number 1. This last one, we've got x to the 0 power. That is the only thing that's to the 0 power. There are no parentheses. Everything else stays the same. So I still have 7 to the 3rd. This now is the number 1. And we still have y to the 3rd. Now, normally I would just leave that, but I can actually simplify 7 to the 3rd. 7 times 7 times 7, we actually figured out a couple slides ago, is 343. If you're not sure, plug it in. So that means I have 343 times 1. Well, anything times 1 is itself, so 343 times 1 is still 343. So those are gone now, and then I have y to the 3rd. So there's my final answer. You don't have to do the independent practice right now if you don't want to. There's a homework assignment on the back.